And let's decide which parameter we will check. Let's check the comment parameter, and for the columns, let's check the top level parameter. Copy the command to run the script. We pour the MD script here once more and run the process. The plugin has worked successfully. See that a new table has been created. Go into it, and now let's see that the check has been performed. The data for these elements have been filled in, and it showed us the number, more precisely the number of elements with filled data.
Every day and week, data managers are tasked with validating dozens and hundreds of projects in various CAD/BIM formats. It takes hours and more often days for managers to verify the data to produce the necessary report. Different types of data requirements make the job of validation simply unbearable. However, by switching from complex and parametric formats to structured and granular data, the process of data validation can become incredibly efficient and swift. A consistent and unified data schema across all formats enables you to work with project data and validate it with just a few lines of code or simple spreadsheet applications. A fixed, structured form of data significantly simplifies processing and enhances efficiency by tens or even hundreds of times.
Hello everyone. Today we will look at a tool for checking data from Revit and IFC files without using Revit itself and an IFC data viewer. Actually, we are on the repository page where this tool is provided. This is a script written in Python. So what do you need to do to use it? First, you need to download it. Click on this button and download the archive. Next, scroll down and read the overview of its capabilities. We also have additional requirements for the script to work. We need to go to the Data-Driven Construction PO website, where you can download, or rather must download, the converter from IFC format to Excel tables, and from Revit format to Excel tables. Accordingly, in addition to this, Python must be installed on your computer. Here is a link to Python. Go there, download the latest version, and install it. Additionally, when installing Python, make sure to check the box to add Python to the system paths. Moving on, well, here we have a version check. If you downloaded the latest one, you don't need to perform the check. The version should be above the third, and we also need to additionally download the necessary libraries that the script uses. For this, we copy the Git. Hello everyone. Today we will look at a tool for checking data from. Paste the text and press enter. After that, we got some information. In this case, the command line tells me that these libraries are already installed and suggests updating them, but I won't update them since everything works with the old libraries, so as not to waste your time. So let's move on directly to configuring the script itself and its accompanying files. Let's go to the folder where I have already downloaded the archive, unpacked it, and I also have two folders with converters here, the IFC converter and the Revit converter, which were downloaded from the Data-Driven Construction IPO website in Chorley. To better understand how all this works, I will now open the folder in a new window. This one. Let's see what we have here. Well, we have a file with instructions that repeats our page on GitHub. And we have our Excel spreadsheet. Let's open it. I'll group it on the right like this. First, we will be testing a Revit file. Here we have two files, and we will also test an IFC file. These files are open in Revit. This is the first file, which has only two walls, and the second file, which has walls, a floor, and columns. How do we conduct the check? Let's take a look. Here we have the first column, where we specify the elements that are in the files to be checked, and in the second column, we specify the parameter that will be checked. How do we find the necessary names of our elements or categories? For this, we have a reference page that lists the names of the elements inside our script and how they are named inside the Revit file. And let's take a look. We have a large number of elements inside Revit, but there aren't as many in IFC. For example, if you want to find some elements like assemblies, you copy this text and let's paste it here. And also look at the comment parameter, save it. Besides this, we also need to make a number of other settings. First, we need to specify the path to the file that we will be checking. We copy the folder path, paste it here. Add a slash, and I want to check this file. Copy its name, paste it here. We also need to specify the path to our converter, specifically to the data-driven libs folder. This folder is located inside the converter folder. Here it is, and I go here and copy and paste it. Well, it hasn't changed because it was already there beforehand. I go back. There. We save our Excel file and it needs to be closed. Next, the final setup remains. This is the setup of our script. We open the script by right-clicking. You can edit it through Notepad, but I find it more convenient to edit it on a laptop. Here, I have opened it. You need to specify the path to our table here. We also copy the path, paste it here, and copy the name. I have everything set up in advance here. I'll just close our script. Now, to run our script, we need to do the following. Let's go to the page and see how to run it. Here we have a small instruction. We copy this text, minimize our browser, click here, and then open the command line in this folder. For this folder, the command line was called, and here we paste the text we need. In B, the script will start executing. The script will run our converter so that we don't have to start it manually, and it will create a report file. We can close this window. We can observe here that an Excel table has been created with a description of the data inside our Revit file. There is a large amount of data here. If I scroll down, we will see our two walls that are in our file. I will close them. And we also have a 3D representation file of our Revit file created. These are our two walls. We will close them. Now let's look at our report, how it has been processed. I open it and we see what happened. Our file was checked, and since we don't have data elements with the specified parameters, they are highlighted in red. Accordingly, our script showed that these elements are missing and their fill rate is 0. The script showed that we have walls inside our file and these parameters are filled in for the walls. Here are the parameters that are filled in. Using commas, we can directly see the values themselves and then somehow process them. Now let's look at the second file and try to work with it, as it has more objects. I'm closing the table, we don't need it for now. And I'm switching to reverse. Look, besides the walls, we have floor objects and 2 columns. Well, let's try to check for overlaps and 2 columns, as well as the filling of some parameters. Using our table, we open it. The template of our table. I will do it like this. I will set up our Revit window so that the elements are visible. You can even close the cave here. Now look, I select our object. See what it's called? It's called Flores. I go here. And also our floors. And I see how to name our object inside our script. I copy the name and paste it down here. And let's decide which parameter we will check. Let's check the comment parameter. I'll go here, select it. Oh, I already have a comment. I'll copy it here and paste it here. And here we will simply take a comment filled in. Let's say test 1. We also have our columns. Here, columns. We will be looking for them inside our tables. We simply go to this sheet and write copy. I'm copying the comment here now, the name, and for the columns, let's check something else. Let's check the top level parameter, save the table. Additionally, we need to change the path of the file that we will be analyzing, and we naturally save the Revit file so that the changes we made are preserved. And we need to specify this file as the file for processing. I copy the name and paste it here. Now I save the table again. It needs to be closed, and we need to run our script again. Copy the command to run the script. We pour the MD script here once more and run the processor. The plugin has worked successfully. We close it, see that a new table has been created, go into it, and now let's see that the check has been performed. The data for these elements have been filled in, and as you can see, something is filled in, something is issued, and it showed us the number, more precisely the number of elements with filled data. This is how our script works, and as a final check, let's check our IFC file. We need to reconfigure our table. Here we change the path to the file. We select RVT, more precisely IFC, and here we need to change the path to our converter. We select this converter, this folder, copy, paste. We also need to go back, and let's see what we have inside our IFC file. Let me open it using this application. Let's see what parameters we have inside our file. This is a wall type, specifically an IFC wall standard case in our category. Let's enter it twice and choose one of the parameters. Let's choose this parameter and probably this parameter as well. I'll save, close the file, and open the folder with our script. I will open the command line and run the command to execute our script. The script has finished running and created a file with the last digits 209. Let's open it. And we see that we have these parameters for 2 walls. This way you can also check all files using this script. Thank you everyone.
Check out other examples of pipelines on open data and open source tools for construction business cases at datadrivenconstruction.io.